Good morning, good afternoon, wherever you are, and welcome to migrating your MQI applications to JMS. If you don't know who I am, my name is Matt Lemming. I'm the architect for MQ for ZOS, so I spend all of my time working on the mainframe and trying to figure out what MQ should do next, and how we should carry on integrating tightly with the ZOS platform. This presentation isn't strictly a ZOS specific presentation. It's kind of cross-platform really, but the inspiration for it was Z specific. So some of you may have heard for Watson Code Assistant for ZOS, which is all about modernizing applications written in COBOL and converting them using a large language model to Java. And so that's a piece of work that's been going on at IBM for some time. And I've been involved with that from an MQ perspective. And that got me thinking about, ignoring the LLM and the Watson Code Assistant side of things, what would I need to do if I was migrating from MQI applications into JMS? And it got me thinking about all of the interesting points and the challenges. And that's why I've written this presentation. So hopefully I'll go to the next slide. Where's my cursor gone? Always exciting. There you go. Probably there you go. So, as a bit of scene setting, I'm sure most of you know this already. MQ supports a wide range of APIs. So more recently, we've added support for things like REST, or for Go, which is an open source API we've got. But for a very, very long time, since our kind of the product was originally created, we supported the MQI, or message queuing interface. And this is kind of our most fundamental MQ specific API, and we support that in a wide range of languages, and that's the one right in the middle. So you can see there's a big list of languages there, and that's been around since MQ's been around. JMS, which is a Java-based API, which is the Java messaging specification, is another API for MQ and for other messaging products, and we supported that for almost as long as the MQI. And really, what I want to talk about is how, if you've got an existing applications written in MQI and you want to modernize those to Java and therefore to JMS, some of the things you need to think about. What gotchas are there? How do you convert? Where are the discrepancies in that conversion? And what other things do you need to think about as well? And the reason JMS or Java has been chosen as a modernization target is because Java has been around for a long time, and there's lots and lots of skills there in the market. So it makes a natural thing to use for a modernization target. And we see lots and lots of customers still writing applications in Java for MQ and many other things. So even though there's the rise of languages like Python, which you can also use with MQ, or for RESTful frameworks, Java and JMS is therefore still a really good programming language to use with MQ. So if you were to modernize from the MQI, JMS and Java would make sense. But before I get into the details of that, what I wanted to call out is the fact that I'm not saying here that you should, moving away from the MQI is not something you should do or have to do or anything like that. The intention for the MQI is that it is and will continue to be for the, for the foreseeable future, the main API for MQ. So we're not saying we're getting rid of the MQI at all, and there's a need to modernize because of that. What we're saying is, because the MQI supports such wide variety of languages, some of those languages are starting to get a little bit old in the tooth, and skills in them are becoming more and more limited. So COBOL being the prime example of this. During the lockdown, everyone was talking about how COBOL skills are declining massively, and so there's a need to modernize off COBOL, and in this case, it'd be off the COBOL MQI to something like JMS. But actually, that's not the only language, right? So high-level assembler is also supported on ZOS, and skills in that are relatively rare. I should, of course, add that last week I was talking to a customer who was looking at adding some code to their high-level assembler MQ application, and they were going to start adding extra things. So it's not saying assembler's dead, I'm not saying COBOL's dead. I'm just saying that we are seeing more and more customers transition from a skills purpose over to something like Java, and that's the reason for this presentation. So if you're using things like C or anything like that, this presentation is perhaps less relevant, but they might still be if you're trying to move to frameworks like JEE and migrating a C application to a JEE environment in Liberty or the Web Application Server framework. And then the other thing I wanted to say is that actually MQ has two Java-based APIs. There's the MQ classes for JMS, which is what this presentation is going to focus on, and there's the MQ classes for Java. And I wanted to call out specifically that the MQ classes for Java is actually a mapping of the MQI into Java. So at first level, if you'd look at it, the MQ classes for Java, you might think that would be a natural migration path from MQI written in COBOL, say, to MQI written in Java. That would seem, quite logical. However, we would recommend against that, and that's largely because the MQ classes for Java have been functionally stabilized. So we've not deprecated them. We're not planning on getting rid of them at any particular point, but they do not have the same level of capability as the MQI, and they do not have the same level of capability as the MQ classes for JMS. So we would not recommend using the MQ classes for Java unless you really have a very specific use case. If you're modernizing your applications from the MQI, then we'd recommend you go to the MQ classes for JMS. So high-level comparison before I go into the nitty-gritty details. As I hope I've kind of impressed upon you, the MQI is IBM's premier proprietary API for MQ. Like, it's very specific to the product. It was written and designed specifically for MQ. JMS is, however, quite different. It's a standards-based API for messaging. That means it was designed by committee, which IBM was part of, and there was a number of other companies part of that. So it doesn't in itself know anything about MQ. It abstracts messaging into a generic way of doing messaging. So there is quite a different approach, of course, because it's messaging. It's got the idea of messages and queues and topics and all those sorts of things, but it's not an exact one-to-one map to the MQI, and you'll see that in detail on the following slides. And with the MQI, obviously, it's an MQ-specific API. Therefore, any applications using it are very specifically MQ aware. With JMS, your apps may or may not be MQ aware. It depends on whether you stick to the standard interfaces and abstract away the configuration. And again, I'll touch back on that in a minute. So as I showed in my first slide, the MQI supports a wide variety of languages, some modern, some less so, whereas JMS is really only an API for Java, but it has inspired JMS-like APIs in other languages, such as Go, and it also inspired the XMS set of languages as well. Because the MQI is an MQ-specific API, it supports every capability, or pretty much every capability, with the exception of about one, that MQ provides. And those capabilities normally come to the MQI first and then trickle down to the other languages. JMS, because it's standards-based, supports most MQ capabilities, but some of those that are very MQ-specific don't necessarily fit into the JMS API and therefore are not available. And also there are some cases where, because the JMS is a standard and we have to pass standards compliance tests, we've had to add some bits of function specifically for JMS that we don't think are necessarily a perfect wider fit into MQ as well. So there's kind of, we get the odd discrepancy where JMS has a particular capability and MQI doesn't, and that's because we had to add that capability to JMS. I think in both cases, MQI and JMS are widely integrated into all of the environments that MQ will run with. Certainly, if you're looking at MQ on ZOS, then both are tightly integrated with Kix, IMS, and Batch, as well as the WAS environments as well. And then, because both of these APIs have been around for a very long time, they are widely used by customers. We see lots and lots of customers making use of JMS, and probably almost, maybe a little bit more making use of the MQI, but it's starting to get to the point where we see lots of customers using JMS, and it's almost about the equivalent to the number of customers using the MQI. And of course, many will mix and match as well. So let's start looking a little bit deeper, and let's have a bit of a deeper dive into what JMS is. So MQ last year celebrated its 30th anniversary. So we've been around for a long time, been powering the world for a long time. And JMS, so the MQI therefore has been around since 1994. JMS came around shortly after in 1998. And as I've said, it was a collaboration between a number of other companies, including IBM, to provide like a generic API for doing messaging. And that API has changed over time. So the key versions are called out on the left. So the initial version, JMS 1, kind of did all the basics, did point-to-point and pub-sub, but those domains, so point-to-point being one domain, pub-sub being another, were done using a separate set of classes. So if you wanted to do point-to-point and integrate that with pub-sub, it was not exactly complicated, but it wasn't as trivial as it could be. There was entirely separate set of class hierarchies for point-to-point and pub-sub. And that was rectified in JMS 1.1, which basically commoned everything together. So you didn't have to care in great detail about whether you're interacting with a queue or a topic. It kind of made it generic. And for a long time, JMS 1.1 was kind of the main thing to use if you're doing JMS. JMS 2 came out in the MQ8 timeframe. So now we're talking, I'm going to say 8 years ago, but I'm probably not quite right there, but quite a while ago. And this was a massive change in the API. So they changed the interfaces significantly. They introduced this idea of a JMS context, which represented a connection to a queue manager. They changed the exception model, and they also introduced a number of other interesting capabilities, such as delivery delay. And then more recently, in the last couple of years, the JMS 3 standard was introduced. And this is actually a change from who owns the standard. So the earlier versions were owned by Oracle and Sun. And then JMS 3 has actually moved to Jakarta Enterprise Edition, which means the package names all changed, but the API basically remains the same. So going forwards, if you are going to do anything JMS related, whether with MQ or anything else, then the recommendation is use the JMS 3 interfaces, and that's what this presentation is going to focus on. And you can see on the right-hand side of the screen, like a high-level view of the main classes. And there's kind of two sets. There's administered objects, which are the things up top, and then there's the main APIs that you use for actually writing your application, and those are the ones in grey down the bottom. So the administered objects are really there to abstract away configuration. So they represent how you connect to a messaging provider such as MQ. So a connection factory represents how you connect to a queue manager. And then the destinations, which can either be a queue or a topic, they represent how you know, configuration about that queue. So a queue name or a topic string or something like that. And once you've got those administered objects, you can then create the JMS context and the other object Java objects from them. So just a little bit more about administered objects, because this is quite a difference between how you do MQI and JMS. So because JMS is a vendor neutral API, it knows nothing about it knows nothing about queue managers or how MQ does its own queuing functionality. It just has these abstractions. And what you don't want to do if you're writing to the JMS APIs is start to bake in things about MQ or things about specific queue manager. That's kind of what you're trying to avoid. The whole point of JMS is to abstract all that away, and in theory to allow you to switch out one messaging provider with something like MQ. And obviously we'd always recommend to use IBM MQ rather than anyone else's messaging provider. And the idea of JMS administered objects is they make that easy, but by hiding the configuration. So rather than in your code configuring a connection factory to say, here's a particular queue manager, you connect to it on this host and port, what you do is you get that configuration in a text format, and you basically bind it into a JNDI repository. So JNDI is something called Java Naming and Directory Interface, and it basically represents a way of loading configuration and being able to look it up via a text string. So what you do is you pre-configure connection factories, you pre-configure any destinations, so they're specific for MQ, and that's step one, and that's done by an administrator. And then from your applications, you look these resources up from that JNDI repository using a string. So in this case, that might be JMS CF for the connection factory or JMS Q for the queue. And once you've looked up those resources, you get a fully configured connection to that queue manager or queue, and the application doesn't have to know anything about that at all. So that's kind of the abstraction layer that JMS provides. And you don't really get that with MQ. You do get it a little bit. So we don't get that with the MQI because the MQI is very MQ specific. So you copy a queue name in there and you do MQ specific configuration in there. Obviously, we've got things like CCVTs, which do it to a degree, and you can use those with JMS as well. But it's not a perfect match. So this is how you do the MQ neutral stuff with JMS. In the examples I show, I've not done that because it's much simpler just to have all of everything as a chunk of code. But just bear in mind that where I do have MQ specifics configuration coded into my JMS examples, you don't have to do that. It's just for simplicity that I'm showing that. So I'm going to start off with the basics, connecting to MQ. Obviously, this is kind of fundamental. And to do that with the MQI, you basically either use the MQCon or MQConnex call. You specify a queue manager name. And if you're doing MQConnex, you also specify a number of extra attributes which you provide via the connection options. Now, with JMS, it's kind of the same sort of thing. You get a connection factory, and as I say, you'd probably look that up from JNDI so that it would already know the queue manager, or in this case, the client reconnection option. So that would all be abstracted away. And then to actually do the equivalent of the MQConnex call, you basically say connection factory dot create context, and that gives you back a JMS context object, which is a standard JMS API. So you would be able to use that API regardless of whether you're connecting to MQ or TIBCO or any other messaging provider. So it's hidden the fact you're using MQ, and now the API is the same regardless of what you're doing. So one thing to watch here, again, because this is an MQ on Z specific thing, if you're running in Kix, you don't, and you're using the MQI, you don't actually have to issue the MQCon or the MQConnex call because there's an implicit connection under the covers to MQ. With JMS, you still have to issue the connection call because that's the thing that gives you a JMS context object, and you need that to do everything else with. So, you know, difference number one, in Kix, you still have to create a JMS context object, even though there's an implicit connection. That's just because you need the APIs to work. Moving on. So once you've connected to MQ, the next thing is you need to interact with objects. And here's where we start seeing more differences. So with the MQI, if you want to open an object, use the MQ open call, and you say something about how you want to open the object and the type of object you're opening. And so the MQI and MQ supports queues and topics, they're the main ones, but also other things. You can open a distribution list, you can open the queue manager, you can, and if you open the queue manager, you can inquire about it or set attributes on it, okay, as well as doing the getting messages and the putting of messages that you do to queues and topics. And once you've done whatever your application is doing, you then close those resources. And for the duration between the open and the close, that connection to a queue or queue manager or whatever is represented by an HObj, an object handle. So let's compare that with what happens with JMS. So the first one is JMS only knows about queues and topics. It doesn't know anything about MQ at the API level. So you cannot open things like a queue manager, you can't open distribution lists, you can't inquire and set attributes on queues or topics. So that functionality, if you're using that with the MQI, then that's something to watch for if you're converting to JMS. So that doesn't mean you can't do it, but the way to do it would be to use another API like the MQ REST API, which is an easy thing to do from Java. So JMS is all about doing messaging. The MQI kind of, in some ways, conflates messaging and a little bit of configuration. So you kind of need to use a different tool in Java world, which is the REST API. So that's quite a big difference. And once you get past that, you start to get closer. So queues and topics, if you want to use those with JMS to send messages to a queue or a topic, then you create a JMS producer object, and that's kind of this context.create producer API up top right. Or if you want to consume for a queue or a topic, then you could create a consumer, and that consumer, a JMS consumer object, either represents a queue that you're consuming from or a queue that you're consuming from. And the API is the same, regardless of whether it's queue or topic. So again, sort of a simplicity in the JMS APIs. You've also got the ability to browse objects by creating a queue, well, only queues actually, by creating a queue browser object with JMS. And then once you've done your putting and getting to those objects, you close them just like you do, or in a similar way to like you do with the MQI. And again, another little gotcha that's quite tricky here is that with the MQI, you've got the point when you open a queue, you can say whether you want to access that queue to consume messages from it, either via shared consumption or exclusive consumption. There is no way of specifically doing that with JMS. You always take the input model from the queue definition. So another little difference to watch out for. So not insurmountable, just an important thing to call out. So I just also wanted to call out that the JMS producer, which is used for sending messages to MQ, is slightly different, and we'll come back to that slight difference a couple of times as we go through here. But the main difference is the fact that a producer isn't associated with a specific destination, so it's not associated with a specific queue or topic. And so you just create it by saying, create me a producer. And then later on, when you send messages, at the send time, you say which destination you want to send to. And because it doesn't have an object associated with it, or sorry, a backing object in MQ or wherever associated with it, you don't actually have a close method for it. So again, slight differences in the mental model for producing messages compared to consuming messages. And I should say this is where the JMS APIs have changed quite a lot as well. So if this model is a problem for you, then even though I generally recommend JMS 3, you could go back and look at the older style interfaces, which you can still use today because they kind of have a different take on it. So we talked about connecting to MQ, we talked about accessing objects. What we haven't talked about is the messages. And there's quite a lot of mapping that goes on here. So if we look at what an MQI message is, there's basically three parts. There's the message descriptor, which is a standard, or an MQI structure which represents information about the metadata for a queue. Then there's the payload, which is typically a message buffer, and then optionally there's message properties as well. And you have to have the MQMD, and you almost always have a real payload. There's normally you send something in your message. The message properties, however, are entirely optional, and they're relatively recent, for the MQI. So we don't tend to see that many customers using them yet. They are used, but it's not really common in my experience. So if we map that to JMS, there is a JMS message object, of course, because Java is an object-oriented language. And inside that object, there is a header. And that header is a close but not perfect mapping to the MQMD. There is, again, the payload, and then there's properties. And so you've kind of got a broad equivalence between these the two formats of what a message is. The payloads are pretty much perfect one-to-one map. So a message, an MQI message with a payload, that payload will be represented in an equivalent way in JMS. And then the headers and properties, there's a blurry mapping there. And I'm not going to go into that in too much detail because it's quite complicated and it's, like it would take forever. So I'm not going to do that. I should mention that JMS has 5 different types of messages, of which only 2 are of interest from this presentation. That is text messages. So this is where the payload is a string, and that's a direct equivalent to an MQI message where you have an MQMD format of string. And then there's JMS bytes message where the payload is a uninterpreted string of bytes. And that basically maps to any other MQI message. The other 3 object types that JMS supports are very specifically to do with Java objects, so they don't really map onto the MQI world. So you could use them if you modernized your application from MQI to JMS, but it's not a direct comparison, so I'm not going to cover that here. So message properties. So as I said, this is relatively, like now we're talking probably 15 years maybe for the MQI, so relatively recent, but they've always been a part of JMS. So right from the beginning, JMS had the idea of message properties, and the message property is basically an arbitrary name value pair. So if you were sending a message that represented a car, then that there might be a message property saying that this was a particular model of car and a particular color, and you'd represent those as different message properties. And the idea of those message properties is its message metadata that's kind of separate from the core part of the core body of the message. So sometimes you could take those properties and just stick them in the payload. Sometimes it's simpler to have them as message properties. It really kind of depends on how you do it. So from my perspective, I think the JMS APIs for interacting with message properties are simpler. You basically set or get message properties via a set of set string properties or get int property or something like that. An example shown on the bottom right. You can do equivalent things with the MQI. There's just a few more steps to doing it, but you can basically, there's basically parity between, or close to parity between MQI and JMS. And when you use JMS and send a message with message properties, or actually a JMS message in general, those message properties get sent as an RFH2 header, which is an IBM MQ standard header that sits on the front of the payload. Okay, and we'll come back to that in detail later. The other thing I wanted to talk about is I said there was kind of this hazy mapping between the JMS header and JMS message properties and MQMD properties, and that's because if you want to set specific MQMD properties with JMS, then you can, but that's done via message properties, and you can see that in the bottom left hand here of this image. You can do something like message.set int property JMS underscore IBM report option, and that allows you to say, in this example, set the MQMD report field. So if you want to use MQI specific attributes from JMS, you can via message properties, but obviously you're starting to break the abstraction layer a little bit. But this is like a standard way of doing it with JMS. Just bear in mind it's not as portable, but hey, we'd hope you wouldn't move away from MQ anyway. So sending messages. So at a high level, everything is very similar here. So with MQI, once you've created your message and you've got your MQMD configured and your message buffer with your payload, then you can send that via either an MQ put, in which case you open the queue, put one or more times, and MQ close it. Or you can do an MQ put one, which does the MQ open and MQ close under the covers. And you have both of those choices with the MQI. With JMS, you use the JMS producer object I showed you earlier, and that always does under the covers an MQ put one. So there's no idea with the JMS 3 interfaces, the JMS 3 standard interfaces, to do an MQ put. Okay, so that's one thing to be aware of. It's therefore slightly less efficient, and it's worth bearing in mind that you can use the JMS 1 style interfaces to do MQ opens and MQ put equivalents with JMS, and that's done via a message producer object. So that's an older API, still supported. It does do this. It's just worth bearing in mind if you use the recommended API, you're doing MQ put ones under the covers all the time, which does have a slight performance difference. Just again, something to watch for. So, and other than that, I think sending of messages it's kind of largely the same. So receiving messages, again, very, very similar. And I think this has probably got a much closer mapping than for sending messages with the MQI. So for JMS, if you're going to receive a message, use a JMS consumer object, and that's associated with a specific destination, either a queue or a topic. And largely, you've got the same sort of options that you have with with the MQI. So you can receive a message without waiting for it, or you can receive a message and wait for 10 seconds or a minute or something like that. And you've also got the ability to go and receive a message, but look for a very specific message using a message selector. And again, you have that capability with the MQI. And some of that's done via looking, like if you're looking for a message with a specific message ID or correlation ID, then you can use the MQ match options with the MQI. And there's an equivalent way of doing that by using a specially formatted message selector with JMS, and that's kind of shown in the middle right-hand side with the ID prefix. And that's the optimal way of doing it. But also, if you want to go and look for, say, a message with a message property saying it's a color blue and it's a car that's a Volkswagen, you can do that with both. It's not particularly performant, that approach, and that's the same regardless of whether you're using MQI or JMS, but you can absolutely use arbitrary message selectors to pick specific messages off a queue. So close mapping here, generally, there are some nuances, and one of those I'll specifically call out is that with the MQI, you provide a specific buffer to receive a message into, and you therefore need to care about whether that message, that buffer is big enough. And if it's not big enough, you need to resize it. All of that is hidden under the covers for you in JMS. If you use JMS to receive a message from MQ, then under the covers it is using a buffer, but the resizing of that is all dealt with dynamically. You don't have to worry about how big the message is. JMS sorts all that out. So again, here that's an example of a simplification in terms of coding that you can benefit from if you're using the JMS API. So if anyone's got any questions as I go through, feel free to ask them, and I'll either answer them at the end or on the fly. I don't think I've got any. I did see something pop up in the chat, but I wondered if that was just a generic thing.
Just me saying,
yeah,
the questions there.
Yeah, that's cool. All right, thank you. So yeah, anyway, I'll just carry on talking. So this is why I've lost my cursor. There you go. Browsing messages. Okay, so this, if you look at what the MQI has, it has a rich set of APIs for browsing messages. You can do lots of things with browse with mark, browse cursors, and you can kind of flip between browsing and destructively getting messages. So it's actually, the MQI has a very, very powerful browse capability. Unfortunately, that doesn't really map to the JMS spec. So this is one of those things where, because JMS doesn't really know anything specifically about MQ, we've kind of, you lose something in the translation. So with the JMS API, if you want to browse something, you can browse a queue, and there's a specific object for that, this queue browser object, but it's very, very basic. You can basically walk through the set of messages on a queue using an enumeration. And then if you then want to do something like destructively get those messages, you don't have a browse cursor to play with like you do with the MQI. Instead, you have to go and create a JMS consumer object and specify the message ID of the message you want to specifically get. Okay, so I'm not saying it's impossible to mix and match your browsing capability in general, but there are definitely deficiencies, in my opinion, with how JMS does browsing, and that's kind of not really something we can actually solve. MQ can't really solve that discrepancy. It's just a difference in the APIs, which unfortunately, with the way JMS is designed from a spec level today, you can't really work around. That said, I think in most cases it doesn't matter. So if you're just doing normal putting getting, then JMS kind of solves 90% or probably 95% of application use cases that you might have used in MQI. It's just with some power users, perhaps JMS is a bit deficient in this area. So Morag, so Morag asked there a question about, does MQI automatically manage message buffers? Yes, it does, and it also deals with all the async consume stuff for you under the covers. I don't cover async consume here because it's kind of, it would have made the session a bit too longer than it already is. But yes, under the covers, the JMS API has the equivalent of async consume, which is done via message listeners, and it deals with all of the message buffers and the MQ controls that you have the equivalent of in the MQI. So it's one of the benefits, I think, of of having JMS. It kind of abstracts away from some of that power, but also some of that complexity that you get with the MQI. So pub sub. So I'm going to do a light touch on pub sub because it's quite a deep topic. So JMS right from the beginning. Right from the beginning, JMS has supported the idea of publish subscribe with topics, and MQ has long had support for publish subscribe, and at various points that was kind of an add-on to the product, and since MQ version 7 it's been built in. And I'm pleased to say that the comparison between MQI pub sub and JMS pub sub is actually quite a good comparison. There's a good level of broad equivalence. So durable, non-durable subscribers, you get both of those regardless of MQI versus JMS. Retained publications, they exist in both cases, and administrative subscriptions also can be used with JMS to kind of hide pub sub if you want to. I think the main thing I would call out here is that if you're using, well, basically MQ has the idea of two different types of subscribers. You can have a managed subscription or an unmanaged subscription. So a managed subscription, then the queue manager is basically responsible for dealing with the queue that ultimately underpins that subscriber, and kind of hides the management of that queue from the subscriber itself. With unmanaged subscriptions, the application is responsible for maintaining the queue that's associated with the subscription. And with the MQI, you can use both of these approaches, and they've got pros and cons. If you're using JMS, you can only use managed subscriptions. So basically, if you create a subscriber using JMS, then under the covers that you use an MQ managed subscription and associate a queue with that JMS application that's subscribed to that application. So again, something to bear in mind, the difference there if you're going from the MQI to JMS. If you're just using managed subscriptions, it should be a relatively seamless conversion. If you're using unmanaged subscriptions, you have to do a little bit more work, and you'd probably go for doing something like an administrative subscription instead. But just bear in mind there are differences there, and that require a little bit of extra work to do that mapping. How are we doing for time? We've got 20 minutes left. Okay, so moving away from the fundamentals of the API, let's look at some other bits. So transactions. So this is an interesting area, I think, when you look at comparing how MQI works and JMS, because while both of these APIs have the idea of a transaction, the model is very, very different. So with the MQI, basically, there's kind of an implicit transaction always available under the covers, basically, and that transaction is either owned by the queue manager, or it might be owned by KICS, or it might be owned by IMS, or it might be owned by RRS. And basically, when you send a message via an MQ put or get a message via MQ get, you have a choice at the point of sending or receiving whether you want that message to be got or put inside that transaction. So up the top, we show an example where we do a put inside sync point, which means that that message is now being put under a transaction, so you can roll it back. And then we can then send the next message outside of the transaction, so MQ PMO _ no sync point, which means it's now not being sent via transaction. And you can do similar things with MQ get, and there's even an extra option with MQ get called sync point of persistence. So it kind of depends whether that message is persistent or not as to whether it's got under a transaction. And then you go and commit or roll back that transaction. So that's all great, but you have that real flexibility on a per message basis. JMS does things quite differently. So when you connect to the queue manager, so this is effectively MQ con time, for that connection, you decide whether, and at the point you connect, you decide whether messages sent or received are sent or received inside that transaction. So you don't have a choice. Either everything is sent in that transaction for that connection, or nothing is sent in the transaction, or sent or received, sorry, in a transaction for that connection. So it's very much upfront, what do you want to do? Do you want to send and receive messages in transaction or not? and you have to know in advance, and you create your JMS context based on that information. And if you decided for it to be a transacted context, then you do your messaging all inside the transaction, and then you either commit or roll back, just like you do with the MQI. But you need to know in advance. So quite a difference. Now, that doesn't mean you can't do something equivalent to what MQI does. You just need multiple connections. You need two JMS contexts, one that's transacted, one that's non-transacted, and then you can do something that's equivalent to the MQI. It's just done in a different way. Okay. And I've got an example. My second example, the create context with no parameter, shows you how to create a non-transacted connection to MQ. And then there's also extra subtleties available in JMS for receiving messages. You've got the ability to receive messages not in a proper transaction, in a JMS transaction, but instead you've got the ability to acknowledge them, which is quite a common thing with modern messaging APIs, the ability to receive messages. And when you process them, you basically acknowledge up to the point you've received. And again, that's done under the covers with an MQI style transaction, but it's exposed differently. So just worth bearing in mind, the main thing is the mapping is quite different here. And this was an interesting area when you look at how to do it from an AI-based large language model auto conversion. It starts to get quite tricky. So definitely something to watch for. So if you're converting your application applications from MQI into JMS, then you're probably going to do that in a piecemeal manner, right? So there's likely to be periods of time where your application will be a hybrid one that's partially MQI and partially JMS. And in fact, we see this all the time, right? The whole point of MQ is it's to allow applications to talk, and those applications don't have to be the same. So you can have an MQI application talking to a REST API application. You can have an MQI application talking to a JMS application, and lots of customers do this. But it's obviously quite important when you're looking at converting and migrating your applications from MQI to JMS as well. So this is absolutely doable. You just need to bear in mind a few details, and the nitty-gritty details are in that link down the bottom side of this slide. So as I've already mentioned, the point where MQI and JMS messages meet is either by text messages, which are those which have an MQMD format of MQ string, or everything else is dealt with via JMS as a binary message. So if you send a string format message from MQI into JMS, then that is received as a JMS text message in that JMS application. If a JMS application sends a text message into the MQI, then that is received as a standard MQMD and message buffer, and the MQMD has a format of string. Everything else is done via a JMS bytes message. And if you want to do things specific to a format, then you can go and either set a format in the JMS world via the string property I've shown in the bottom left-hand corner, so the JMS_IBM format attribute, and then that is a direct mapping to the MQMD.format field. So you can kind of communicate your formats between these two APIs very simply. If you want to get the next, well, actually, so let's talk next about message properties. So as I've mentioned before, when you send a JMS message, then by default, that message will have an RFH2 header stuck on the front of it. And that's basically between the MQMD and the message payload. And the RFH2 header contains fields that are specific to JMS message properties. So not all MQI applications can deal with those message properties. And so it's useful to be aware of the fact you can switch off the RFH2 header if you're sending messages from JMS to MQI applications. You can either do that via setting the target client attribute on the queue, which you can do via JNDI, or do programmatically as shown here. It's also possible to do this in a configuration manner via the propctl attribute on the queue as well. So this is just something to bear in mind. You don't need to care about it if you're going from JMS to JMS applications, but you typically do care if you're sending from JMS into MQI. Going the other way around, if you send an MQI message to JMS, you don't have to care about whether there's an RFH2 header there or not. JMS will tolerate it either being present or not being present. It just deals with it under the covers. And again, the nitty-gritty details of these mappings are on that link on the bottom right-hand side. So I should touch on data conversion. This is always an area that tends to make people go cross-eyed with MQ. But in general, with JMS, it kind of works in the same way it does with MQI, right? So data conversion is built on the concepts of the MQMD format, the MQMD CCS ID, and the MQMD encoding fields. And those apply just as well to JMS. You just need to be aware of some differences. And you only need to care about this if you're converting between JMS applications and MQI applications. If you're going from JMS to JMS, you generally do not need to care. It's only when you're mixing between the JMS and MQI world. And probably the most important thing to get your head around is the fact that inside the JVM, every text string as part of the Java spec has to be in UTF-16, okay? So any message you've sent in from the MQI into a JMS application under the covers will likely have been converted into UTF-16, so Unicode, when you're dealing with a text message. So if you send an EBCDIC message from MQ on ZOS via the MQI into a queue and it's received by a JMS application, as part of getting that message via the JMS API, that will that EBCDIC code page message will have been converted automatically via the MQ APIs into Unicode, and that all happens automatically. And similarly, if you're sending a message that needs to go to something that wants that payload in EBCDIC, then you can either do that via built-in MQ conversion capabilities, or you can get the MQ JMS interfaces to do that for you. Basically, when you send a message, you can say, when I send this message, convert it from Unicode into EBCDIC, so code page 500 in this example, and it all happens automatically under the covers. So worth bearing that in mind. And then if you're doing data conversion, then it's a similar sort of story. You can build up a bytes message with your bytes in the format that's being expected by a specific MQI application, and that can either do its own conversion, or if you've got a data conversion exit that has been plugged in to your queue manager, then you can take advantage of that as well. And again, nitty-gritty details on the link on the bottom right-hand side there. So, can be a bit tricky, but it absolutely can be made to work. You just have to have a good read of the documentation and not forget that JVM is always implicitly in Unicode. So we're kind of getting to the end of the slides, which is good because my voice is starting to run out. So I'm going to touch on dealing with errors. I think the main thing here is that with the MQI, it's procedural. So everything is, if you do an MQI call, you'll get a completion code and a reason code, and you can do something with that. JMS, because it's a Java API, everything is done via exceptions. Okay, that's the standard way to deal with errors in a Java environment. So doing anything else would be strange. The thing to watch for is that the JMS API has two types of exceptions. There's a JMS exception, which is a checked exception, so you have to catch it or throw it. And there's a JMS runtime exception, which is an unchecked exception, so you don't have to catch it. My very, very strong recommendation is always catch JMS runtime exception, because if you don't catch it and you get an exception, it will end up in your JVM terminating. In my opinion, this is a kind of a flaw with the JMS APIs. So you should catch both whenever you do a JMS operation, or at some level at least. And then there's a procedure you can use to map down from the JMS exception, JMS runtime exception, which are standards-based exceptions, into something that is an MQ exception, which basically holds the completion code and the region code. So that's kind of shown on the right-hand side, which is a simplified example. There is a full detailed way of doing this in the bottom right-hand side. So any exception handling or error handling you'd have had with the MQI can be mapped to JMS. It's just worth bearing in mind that the procedure you use for that is a formulaic, but a little bit more complicated. And also you should bear in mind that sometimes a given JMS API might map under the covers to multiple different MQI APIs. So again, there's a slight nuance there. Okay, defaults. Another little interesting area. So JMS has its own spec-defined set of defaults. So when you send a message with the JMS API, the default priority is 4. MQ and the MQI has its own set of defaults, and they are different. So the default for MQI is taken from the queue, and therefore the default message priority is 0. Okay, we've seen lots of customers who converted from MQI to JMS, and suddenly they find their priorities changed. Now, normally that doesn't matter, but it can do if you set a specific value in some cases. So one thing to look out for. Another one is by default, JMS sends persistent messages, whereas by default, MQI will send non-persistent messages. So again, another nuance, it is possible to make those defaults work, and that's the example in the bottom right-hand corner. And it basically says, for this queue, any message I send, set the priority to be the default from the MQQ configuration, and the same thing for persistence. So delivery mode is basically a synonym for persistence. And then the last thing is that not every MQ platform has the same default. So for example, in MQ on ZOS, messages by default are put and got in sync point. On other platforms, they aren't. And what MQJMS does is it actually has a common abstraction. So it has the same default regardless of platform. And of course, with MQJMS, you actually tell it up front whether you want a transaction or not. But by default, there isn't a transaction with JMS regardless of platform. So again, a little nuance to watch. So I think it's important to ask, we've said quite a lot of things where you get extra things with the MQI, but also there are cases where you get more stuff with the JMS. And I think the first one of these is the main benefit that JMS is a standardized API. Therefore, there are lots of platforms and frameworks that build on the JMS API, regardless of whether it's MQ's JMS API or other APIs. And so those frameworks make application development simpler. And you don't get the equivalent thing really with the MQI. Okay, and so key frameworks, and there's many of these, are Java Enterprise or Jakarta Enterprise Edition. This is a massive framework for writing enterprise applications in Java, and it provides lots and lots, tons and tons of capabilities, of which the JMS API is just one small part. So, you know, that's a significant differentiator between that and the MQI. The MQI is something to use if you've got lots of messaging and you're dealing very specifically with MQ. But if you want to write something where the framework does a lot of your application capabilities for you, it's quite hard to beat something like JEE. And then that's been evolving over time. And now we see things like Spring and Spring Boot. Again, these under the covers make use of JMS, and they can be plugged into the MQ JMS APIs or anyone else's JMS APIs. And again, they provide a lot of simplification from writing your applications, which, you know, is definitely a benefit compared to the MQI. And then I've mentioned before that when JMS 2 came along, that introduced delivery delay, and that's a capability that you only get with JMS. It's not available in normal MQI and allows you to send messages, and they only become available after a period of time. And then there's the last thing, which is JMS has built-in support for the backout queue and backout threshold attributes for poison message handling. You have to roll your own support if you're using the MQI for that. And then last slide, performance. I think it's fair to say that while JMS performs very well, it's a fast API, the MQI itself is kind of that little bit closer to the queue manager. And so the MQI generally outperforms JMS. So if you really are right at the edge and really wanting to put vast amounts of data through MQ, this is something to be aware of. So here's an example performance, some example performance numbers on Linux. Green is JMS, red is MQI, and then the thick line is message throughput. So you can see the red thick line is a big chunk higher than the green thick line. So that's the MQI being able to do more messaging. And the thin line is CPU. So the green thin line is higher than the red thin line, and that means that the JMS API is kind of more costly, and that's kind of probably down to running in the JVM and garbage collection and all that sort of stuff. So worth bearing in mind, they do not perform the same. And there are some things you can do to mitigate that, connection pooling being a very good one, and things like Spring and J solve that problem for you, but they just worth bearing in mind the difference there. And then that is me. I'm done. I've got 3 minutes left. Recommended reading. So this is like a high-level summary. All of the nitty-gritty details are obviously in the Knowledge Center. There's some good examples there. On the top link is basically how do I write my first JMS application? So it's the very basics. And then the middle chunk of links there are basically the high-level JMS topic in the MQ Knowledge Center, and basically how to map between JMS and MQI, which is obviously important. And then because JMS is a standard API, the last couple of links links to the spec and the Java doc. So we've got 3 minutes left. Has anyone got any questions? Or has everyone gone cross-eyed or fallen?
No, it's just an observation, really. It's really useful. I mean, we've got quite a lot of JMS, but we don't support it directly because we support MQ on Z, and it's typically connecting from distributed. So, whilst not from a migration bent, it's still really useful JMS background and information in the presentation anyway. So it's yeah, really useful overview. Thanks for that.
Okay, no problem. And I imagine what you'll see is, like if this is as well as those distributed applications using JMS, you might see your Kix applications and IMS applications over time modernizing, because we do see that it's becoming a more common trend. So maybe something to have in your back pocket for when and if that happens.
Yeah, sure.
Brilliant. It was great, Matt. Thank you very much. As Paul mentioned, it's very information packed and obviously a lot to take in. So we do appreciate your time and your the presentation. If anyone, I have allowed people to unmute, and as Paul just did. So if anyone has any questions, please shout. But apart from that, I hope you're okay for me to say this, that if anyone has any questions directly to Matt, just ping him an email. His information is in our agenda. We obviously have a resource now that we know who to go to, so please utilize it. And obviously the presentation has been recorded, so you will be able to review it again to see if anything you missed, or if you want to share with the rest of your team within your area, feel free to do so as well as soon as the link for the recording is available. But yeah, last chance to shout now. I think we're okay, Matt. Yeah, I appreciate this. This has been a very informative and really great. So thank you very much for your time. As I say, the session number is 5B. If anyone wants to leave any feedback for us, for the conference, for Matt, for anything at all, let us know. But apart from that, thank you very much again, and enjoy the rest of the conference.
Thank you.
Thanks. Bye.
Thanks, Matt.
Cheers.